Hello, welcome to this Oracle CloudWorld session, Modern Database Monitoring with Integrated Machine Learning. 72% of IT budgets are spent on maintenance versus innovation. Most of that time goes into identifying the right telemetry for troubleshooting and debugging issues, and then figuring out how to quickly analyze and visualize the data. In this session, I'll be talking about Oracle products and logging analytics specifically on how that can make these things easier. My name is Kumar Varun. I'm the product manager for logging analytics in Oracle Observability and Management. We have a comprehensive set of offering in our portfolio, and our strategy and mission is to allow the best combination of capabilities, features, and offerings that suit the needs of your environment, no matter where you are in your journey. Oracle choice of solutions enable our customers to reduce IT cost and modernize IT, move from operations to innovation, use the abundance of data that you're collecting from your systems to drive better outcomes, make better decisions with insights, and run organizations smarter and more efficiently. In a typical enterprise environment, there are hundreds of applications and servers, which are emitting more than 25 different types of logs from database, from applications and infrastructure. And all of that is powered by thousands of different databases. But managing that is not easy. There are several problems that we see. Technology sprawl being the latest one. Since you're trying to keep up with the market and changing technology landscape, observability becomes an afterthought. Secondly, silos lead to low utilization and in many cases causes security exposure. With all these changes, we are not able to identify the drift, the non-standard configuration. And it's difficult to identify where the deviations happen. And when you're managing this in the flow, trying to keep up with the business, the manual processes and ad hoc automation adds to this. How can logs help? How can Oracle helps in this? Let me introduce you to Observability and Management suite of services, which consist of, at the very bottom layer, the core infrastructure services. We have compute, storage, network, and security, followed by the foundational services, which are metrics, logs, alarms, traces, and operation insight repository. And finally, the advanced set of services like APM, logging analytics, stack monitoring, which are supported by observability and management dashboard and support multi-cloud platforms. Drilling deeper into Oracle Logging Analytics. Oracle Logging Analytics provides an intuitive analytics and log exploration visualization to do multi-dimensional data exploration for problem detection and root cause analysis. What you see on the right is the multi-cloud or hybrid cloud deployment for logging analytics. It's a fully managed SaaS service which can collect data from Oracle Cloud, Azure, AWS, or any on-premises from a multitude of technologies which we have out-of-the-box parsers and sources built in and can be used to quickly visualize, explore, troubleshoot, and identify root causes of issues. We have rich out-of-the-box knowledge content, which I'll go into details on what that means in terms of error categorization with labels, single-click log enablement, and insights from services. And you can have sophisticated dashboards for monitoring and interactive metric analysis. In terms of log collection, here you see we can collect logs from different sources, management agent being the primary source of collection. There are other sources, service connector, integration cloud, from object storage, streaming functions, and fluentd based collection. And intelligence for collection. Collection is built into the product in the sense logging analytics knows where exactly to collect the data from, how to enrich it, how to parse it, so that it's easier for the end user to exactly tell what data is coming in and how to make use of it quickly. Especially for Oracle databases and your ExaData infrastructure, there is expansive coverage in terms of database components that are covered and its knowledge for usage and troubleshooting. All logs are automatically classified into known or used error categories, search and exploration using familiar log categories. For example, you're looking for memory issues or connection issues, storage issues, and these are all extensible by end users. Out-of-the-box dashboards as well as customizable dashboards provide overall health of your database system. Some of the areas which are of importance are when you want to look at the operations of your databases. When you're looking at audit logs, for example, login failures, how many times, and how to monitor connections. Alert logs, for example, system crashes and error occurring in your databases. And database listener logs for use cases like instance start or shutdown, which client did not connect to the instance, with which user, which port. All of this is powered by the ML-driven analytics that is available in logging analytics and can help you simplify your management and troubleshooting for all your database and your entire IT estate. To give you a deeper view of what is automatically collected from Oracle databases is this view shows the multitude of logs or telemetry data that is available for troubleshooting and analysis that you use daily. And when you multiply this by thousands of databases that you might be maintaining, the one-click ingestion really comes handy. These logs are automatically identified, parsed, enriched, and analyzed by logging analytics. So you can get instant value out of comprehensive data in those logs without being an expert at either log mining or database telemetry. Let me show you some of the pre-built dashboards for monitoring and some typical use cases. Here, you see one view of Oracle operations dashboard. Here we have a variety of capabilities that are designed to work hand in hand with Oracle Enterprise Manager to allow you to get maximum value out of your database and ExaData estate. You can add log and other telemetry to your DBA toolkit for better troubleshooting. You can analyze data such as AWR over time for capacity planning, workload rebalancing, and consolidation effort with other suite of services that is available in observability and management. Specifically on logging analytics, ML clustering helps you analyze large volume of logs. You can identify outliers, anomalies, and also SQL trends. It provides you with a single pane of glass with deep insights. Other use cases are out of the box Oracle database knowledge and its usage in troubleshooting. As I mentioned before, all logs are automatically parsed and enriched. And what that enrichment means is categorization of errors. You're converting Aura codes into specific, meaningful, human readable error codes or error codes called labels. And these are all extensible by users. And the expanse of the coverage of the logs is all types of log, whether it is from a file or from a database table. Let me show you another Oracle database dashboard that we use for operations or getting visibility. Here, what you see is what are the different types of databases that you have in your environment. These can be connected through Enterprise Manager or directly connected through logging analytics for collecting and managing telemetry. You see what are the different types of errors and the connection issue trends over a period of time. Number of checkpoints, number of log switches over a period of time and across which databases. On the bottom left, what you see is the CPU utilization and memory utilization versus the corresponding Oracle databases, and an inventory in a single pane of glass view of all your Oracle databases. Another deeper view when you go into operations is the database log trend itself, which can provide deep insight at a very high level when you start in the morning that, hey, what has been happening during a different time zone? And you have critical incidents that that you might want to monitor over that period of time to see if the critical errors have increased or decreased. Identify top database targets which were erroring out during that time range. Here in this case, you see the distribution as well as trend of those top database errors and the corresponding targets. Another important area of growing concern is security. And logging analytics provide out-of-the-box enrichment for security use cases where you want to look at whether somebody has been accessing some sensitive tables, account modifications on high privileges, or schema changes. From all the databases, logging analytics can collect this information directly from SQL tables and normalize it so that you can visualize it across different applications and infrastructure, whether by end user, database, or a specific domain, and quickly troubleshoot and root cause any security exposures that you might be having. Here, you also see anomalies in Oracle databases by number of anomalies that has been happening and number of threats, different shutdowns that might be happening within your environment for the databases, and any account modifications. Another view that we provide out of the box for Oracle database security is this one, where you see additional details in terms of distribution of these shutdowns and startups and threats. Finally, when you're managing a complex environment like this, it becomes important to have ability to do ad hoc analysis where you are able to slice and dice into data. And in an ExaData environment, the number of nodes, the number of different components are humongous. And topology can come in very handy. Here, what you see is the primary view that we have for ad hoc analysis in logging analytics, which provides slicing and dicing capability in a typical, very familiar BI tool-like interface. What you see is the topology of entire Exadata estate in a tiered fashion on how many databases, what hosts are there, the storage layer and the network layer in the same view. And the coloring for these different nodes represent the health of those. It becomes really easy to identify is there any error in my database instances or any specific component. And you can use this to drill down to identify errors. Next, we would like to deep dive into errors from operations dashboard and how to use machine learning for analyzing those. As I mentioned, we automatically parse the Aura codes and convert them into specific human readable messages. Here, what you see is, for example, it's all supported by a rich free from sophisticated query language, and we are searching for Aura-49 star and Aura-003 star. You may be knowing all these error codes by heart. We know you do. And by simply putting them in the query box, we are able to search those across all your log records. But many times it is not that straightforward to remember or a combination of error codes to put in the query bar so that you can get to those results. And that's where the automatic enrichment for logging analytics comes in. Here, what we have done is, as we see those specific error codes from different applications, from databases and infrastructure logs, we attach a specific label to it. For example, here you see an Aura code corresponding to memory error has been attached to this. And all of these can be a starting point. So when it reduces the ramp up time for new users, as well as improve the troubleshooting turnaround time by directly looking at, hey, we are looking at service started issues or abnormal termination issues, irrespective of whether that happened in the top of the stack database or infrastructure in any part of the stack. That makes it easier to start analysis and troubleshoot issues. Not just this, you can deep dive into doing anomaly detection using the link command to identify anomalies. Here what you see is number of these type of errors in this large set of databases that we are managing here. And on the y-axis, you see different types of labels, which we saw in the previous screen. And also the coloring is based upon what type of errors these are. And it makes it easier for you to identify anomalies, which we see on the right-hand side, that there are two anomalous database issues that you might want to start and drill down into. Troubleshooting with out-of-the-box DB knowledge and these labels is extremely easy in Log Explorer, where we show all the parse field, the log source it is collected from, and the time and the corresponding ORA codes. Next, we want to look at the distribution of these error codes across different databases. For example, your ExaData or your autonomous database, and across different types of logs which they are coming in. And from the ORA code, you know, hey, for this ORA 12537, you know, this is coming from a file permission issue, and that can correspond back to infrastructure related or corresponding Exadata infrastructure related issues. We also have extensive coverage for Exawatcher Analytics, where you can get deep dive into specific IO metrics, CPU metrics, etc., and analyze based upon the area, either database weights, CPU weights, IO weights, the corresponding network bandwidth that is being taking IOs, and this is all interactive visualizations and interactive analytics, which is available right out of the box in logging analytics. You can visualize complex metrics coming over a long period of time and correlate them in one page. Now let's drill deeper into how to conduct analysis over a large volume of logs using machine learning clustering capabilities. Clustering is one of the key capabilities that we provide in logging analytics that allows you can think of it as schema on read, that it is able to group logs based upon similar shapes and provide you insights in terms of, hey, I have 40 million or 50 million log records coming in last 1 hour. How do I make sense out of it? Is there any grouping of those? And clustering feature allows you to group those based upon shapes of those records. It can also identify potential issues. These are the events which vary based upon, or which are there in your logs based upon specific keywords that we find. You can also customize these based upon your specific application, and clustering will take that in the form of a dictionary lookup and be able to create those groups. It can also identify outliers and trends across different layers or different log sources. Here, what we see how to invoke the cluster capabilities. When you go into logging analytics, log explorer, in the visualization section, you can invoke cluster by going into visualization drop down and clicking on the cluster view. And it's the one-click ML enablement. And as soon as you do that, we are taking all those log records and converting them into groups based upon the shapes. Now, when you go click there, here what we saw, out of those 15,000 log records, we have converted them into 74 different clusters, that there are 74 different types of groups which are present. And all of them have been parsed on the fly based upon the field or specific sections of those log records or shape which are varying. What we see here is the count of those, trend, a sample message which is highlighted in those 74 clusters, and the corresponding log source. Outliers are the things which happened only once. Typically in an environment, it runs like a machine, that things happen again and again and they repeat. And outliers are the things which happen only once, and they become important in operational and security analysis, so that you are able to quickly identify, hey, this thing never happened in last 7 days or last 24 hours. What is that? So in this case, we are identifying 16 different types of outliers in this specific time range that happened in the last 24 hours. And the same problem category, log source, and the trend is available. And finally, when you're looking at trend analysis, here you can see that different types of events happen at the same time. What are the other events from possibly infrastructure metrics or application that are happening at the same time? And in most IT troubleshooting environment, these things are correlated. So trends automatically help you identify the activities or actions which are happening in parallel. Another area of importance that we want to look at is the top SQL trends, which also uses clustering capabilities. Here, you are able to identify from the database audit logs that what are the top SQLs or clusters of SQL, similar type of SQLs that has been running on your databases, so that you can identify any performance issues or any user related issues if they are valid, if they're supposed to be running those or not. Has there been any privilege escalations or something? And we are able to identify based upon those SQL trends, the trends also based upon, hey, what are the activities happening in parallel from within the SQL analysis as well as your application logs. And you can convert this to answer questions like what is different from this week compared to last week using the automatically available cluster compare utility. When you know that, hey, things are not working fine for a given week, what changed from last week? What is the difference between database A and database B? And all of that can be enabled using link analytics as well as cluster capabilities. This is just tip of the iceberg on what you can do with logging analytics. And as you know, we have hundreds of databases, thousands of databases supporting hundreds of applications, emitting so humongous a deluge of telemetry, which becomes almost impossible to analyze with traditional tools. And you need maintenance for all that data pipeline as well as analysis. It is absolutely critical that the end users, the database administrators, and the application owners get access to meaningful data so that they can make decisions on their own quickly and keep your customers happy and provide the best experience for the customers. In summary, Oracle Logging Analytics provide a very intuitive analytics and log exploration interface right out of the box. You don't have to manage the service itself. They are available as a SaaS service. It is powered by a powerful query language, which provides machine learning capabilities based analytics and has rich out of the box knowledge content in terms of what logs to collect, how to enrich them, and out of the box dashboards, which are customizable and created into sophisticated executive grade dashboards for monitoring. You can further create alarms and alerts based on top of that to create automations. There is an app which is already available in OCI Marketplace for ATV monitoring as a reference, and I encourage everyone to go to the OCI Marketplace or the Oracle Cloud Marketplace to try that out for audit analysis. Thank you so much for joining today's session. For more resources, we have observability and management blog. There is a video series that is available and product documentation. Thank you so much.